Okay, so today we're going to talk about visualizing numerical and categorical data. So share my screen here, share, and okay, so I've got the lab instructions here. I'll just close this video. Yeah. Camera. Got these instructions here that you're going to go through, and so again, we're just going to work through all of these little code chunks. And then what's going to be different this time is that you're going to apply it to your data set that you found. So we're going to look at, first we're going to talk more about categorical data. We haven't really talked about summarizing categorical data, so we're going to talk about that using tables. And then how do we visualize categorical data with bar graphs? And then we'll move into numerical data where we've got a few options. So we can make histograms, or we can make box plots. Often if we want to compare two groups, then side-by-side box plots are a good option. And then I'll show you how to make a QQ plot, which we've talked about in class, but just how to evaluate the normal distribution using a QQ plot, or quantile plot as it's called. And then finally, we're going to visualize the relationship between two numerical variables using a scatter plot. We're going to keep using the CDC data set from the previous lab and where we were working with it. So what's nice is that it'll be kind of a familiar data set. So I'll start a new markdown file here. I'll call it lab 4 work. Why not? And just as before, I'll just clear this all out so that I've got a clean sheet. So 3 ticks, curly brackets, lowercase r, and then close it up with 3 ticks. So again, clear this. Pretend we're starting fresh here. You have to copy and paste your source command, pulling in that CDC data set, just so you have it available in your environment tab. So if we run this, should have kept it. Takes a little bit to get it, but still thinking. Right. So while it's loading, we'll start by just looking at a summary of CDC, just to remind ourselves of what's going on. Right, so here we have the old familiar CDC data set. If we look at the summary of CDC, we get something like this. Even though it looks like we have a summary of X or any and health plan, smoke 100, we don't actually, right? Because those are just stored as zeros and ones. So those are just categorical variables in disguise, I guess. And so the summary command doesn't actually tell us anything about categorical variables. So if we want to dive deeper into categorical variables, then we're going to use this table command. So it's just, so we're going to focus on this smoke 100 variable. And I think I talked about it. The smoke 100 is, have you smoked 100 cigarettes in your lifetime, yes or no? Or at least 100, I guess. At least 100 cigarettes in your lifetime, yes or no? So a yes being recorded as a 1 and a no being recorded as a 0. So we can make a table of this by using the table command, and then we want to use the CDC data set and the smoke 100 variable. So if we run that, right, we get this itty bitty table of 10,559 zeros and 9,441 ones. So there are 2 counts in our 2 categories. Often, right, it's pretty easy to compare these 2 counts, mostly because we only have 2 categories. If we have more than more than 2 categories, or even just in general, you might want to look at the relative frequency. So what is 9,441 out of 20,000? So what we can do is we can just say, okay, give me that table, but actually divide all the values by 20,000. And so that'll give us the relative frequency. Now, these would be easier to compare, especially if we have more than one or more than two categories, right? Say we have 3 or 4 categories, then it's hard to visualize and say, oh, well, I'm expecting to see this count, and et cetera. So 52.7% versus 47.2%. That's easier for our minds to think about. And so we use the table to summarize categorical data. To visualize categorical data, we actually need the table first, because R, to visualize categorical data, needs to know how many are in each category. So we use bar graphs or bar plots to visualize categorical data, right? Of course, we can make pie charts in R. We shouldn't, because pie charts are bad. So bar plots are the way to go for categorical data. Okay. And so we use the bar plot command, and the bar plot command needs, like I said, needs to know that table information, right? How many are in each category. And so if we want to make a bar plot of the smoke 100 variable, then we make a table of the smoke 100 and then stick it into the bar plot. What we've done here is we've nested the table command inside the bar plot command. And that's how I like to do things often, is I say, oh, I need a bar plot. Oh, but first I need a table. So it just kind of ends up being that way. What we could have done, and what I've shown you later, is that we could have generated the table first and called it smoke, right? So make an object called smoke, where smoke is a table of CDC $smoke 100, right? So we can run that, and now we've got this smoke with the 2 values that we're expecting to see. And then we can make a bar plot of smoke, and but it looks the same. I can flip back and forth between these 2 graphs, but they're the exact same. And so why are they the exact same? Well, I'm making a bar plot of smoke, where smoke is the table of CDC smoke 100, which is the exact same here, right? So either we nest them or we can do them separately. It's just a matter of what you prefer to do. And so now you have 2 ways of generating this bar plot. Either way works. If we want to make bigger tables, right? Let's say we want to look at the smoke 100, but also how do those values break up by gender, for example? We can use the table command again, and then our first argument is going to be the gender, comma, the smoke 100. And then it'll generate this table where we have males and females versus the smoke 100, and then the counts in each of those categories. Again, of course, we can divide by 20,000 to get those relative frequencies. So that's all we'll need to know for categorical data as far as visualization goes, right? How to make a bar plot. So now let's move to numerical data. Numerical data, we use histograms, right? We use histograms to look at the distribution of a variable. Is it normal? Is it not normal, right? And so let's say we want to look at the histogram of age. So we want to make a histogram of age. So if we run this, it ends up looking like this. That's great. Here, why is it cut off here? Because you have to be over 18 to answer a survey, right? And so the minimum age is going to be 18, and then there's just fewer people, especially answering surveys, once you hit the 90-year mark, right? And so we've got, I would argue that this follows an approximately normal distribution, just because we have these restrictions. If we want to, we can regenerate that BMI variable that we made last day and look at the histogram of it. So just copy and paste that code for the BMI and run it. And now we've got this BMI added onto our CDC data set just like we had before. And now we can look at a histogram of the BMI. This looks approximately normal to me, maybe with the exception of a few outliers. But remember, we're always pushing for a normal distribution. So whenever you can say, oh, it looks approximately normal, maybe with an exception here or there, that's better than saying it's skewed, right? Because a lot of our analyses are hinging on having a normal distribution. So unless it's clearly skewed, then we can go ahead and assume it's normal. And so I would say, yeah, this looks pretty good. Notice that we're using the defaults here. So here we've got a set number of breaks, right, or a set number of bins. And so here, using the next command, we can alter that by just adding some arguments in our hist command. So hist of CDC $BMI, so make a histogram of BMI, but also now force the number of breaks to be 50. So the number of breaks now, now we have 50 breaks instead of whatever the default was. I guess I could have counted them, it doesn't matter. Okay. You can change things like the color. Oh, that's fun. You can change things like the line width, and you can change the titles, the title of the graph, the title on the axes, right? So you can make all those changes by just adding on inside the histogram command. And you can Google your way to those. But I'll just be looking for a histogram, just base default histogram. That's a good place to start. Okay. What if we want to make box plots? So box plots for a single variable like height, we just use the box plot command. Box plot of CDC height looks like this. This gives us the same information as a histogram would. I don't like it as much. Box plots to me aren't that useful unless you're comparing two groups, right? And so if you want to, we can just double check. You can run the summary command and just confirm that this line is at the median. The median is supposed to be 67. Yeah, it looks reasonable. This line here is your Q3. This is your Q1. And here's your minimum. Here's your maximum, right? And then here is your 1.5 IQR upper bound, 1.5 IQR lower bound. So you can just confirm those values here, but I guarantee you they're all there. So like I said, so box plots are really more useful if you want to compare numerical data split up by two groups. So what we do is we use the box plot command again, and then we want to look at the heights, and then this is the tilde character, so it's like a little kind of wave, and it's underneath the escape key. So if you go shift and then that key underneath the escape key, that'll give you a tilde. And I read it as by. So height by gender is how I read it. You could also read it as height versus gender, or height as a function of gender. All of those work, but I think that height by gender kind of is the most telling. So if I run this, right, now I have two side-by-side box plots, and now it's actually telling me something useful. So now I can say, okay, well, I've got this male group here, and I've got this female group here, and I know that I'm talking about their heights. And so nothing really surprising here, because, yeah, we're expecting our males to be taller than our females, right? What I'm finding interesting is that at the minimum here is about the same, right? And then our maximum is not, right? Our median for the males is quite a bit higher than the median for the females, right? And so side-by-side box plots just let us compare a numerical variable split up by two groups. Much in the same way that we would use subsets, but now we can just keep them in the same data set, right, and look at the height by the gender. Cool. So let's look at a QQ plot. So a QQ plot just lets us determine if we have a normal distribution, or it's just another way to check if we have a normal distribution. Like I said, a lot of our analyses are going to hinge on us having a normal distribution. So we put some effort into, well, do we have a normal distribution? Okay. And so the QQ plot just is one way to check it. And there's lots of others, but we'll just talk about the QQ plot. QQ plot uses the QQ norm command, and we can follow it up with a QQ line command. And the line will just add a quick diagonal line, and an ideal normal distribution would follow that line completely. And so what I was finding on the school computers is that you actually had to run these at the same time. So what you're going to do is you're going to highlight both of them and then hit Control or Control Enter. And then it'll generate both of them at the same time. Usually you'll be able to just, I'll see if it works. I guess I didn't try it earlier. If I run the QQ norm and then the QQ line, it gets added on. But like I said, on the school computers, it wasn't really working, so we had to just highlight both of these lines and then run those. So Command Enter and then run it. So here, like I said, here's our QQ line, right? And this is our ideal normal distribution. So in the middle here, everything is looking really good. And then we've got some lift off here, which we'll tolerate. That's okay. The tails are allowed to misbehave a little bit, right? We know the tails, they get wonky. We might not be too thrilled about this lift here, but I'd say I'd let it slide. I'd probably mention that there's something going on in the upper tail, but right. So as long as you don't have something that's clearly snaking around this straight line, the QQ line, it should be okay. And of course I'm being generous, but we've got this whole chunk that's perfectly on the line, so I'm okay with it. We're just developing rough ideas anyways. So let's look at scatter plots. So scatter plots are how we visualize one numerical variable against another numerical variable. And so we use the plot command to make a scatter plot. And I'm going to walk you through 3 ways that are exactly the same. So they'll all generate the same plot, and it's up to you to decide which one you like more. And then you can just stick with that version for the rest of the labs, for the rest of your plots. So your plot command takes just at its minimum an x comma y, right? So it needs to know what's going on your x-axis and what's going on your y-axis. Remember, your y-axis is your response variable, and your x-axis is your explanatory variable. Remember, explanatory x-axis. And so to be very clear, you could use the plot command and say x equals CDC $height, right? So I want height on my x-axis, and then y equals CDC $weight desired. So then I want my desired weight on the y-axis. I think I made this up. So it doesn't matter sometimes which one's on the x and which one's on the y, but if you have a response variable, that has to go on your y-axis. And so I guess I'm pretending to be interested in someone's desired weight as a function of their height. So how does height explain their desired weight? I'd say it's increasing slightly here, not hugely, but it is increasing a little bit. And that kind of makes sense, right? As you grow taller, your desired weight should adjust and kind of increase as you grow taller. You have to weigh more if you're taller. So another way we could make this plot is we could just cut out the middleman, the x equals and the y equals, and just say CDC $height, comma, weight desired. I can read it all out. It knows the order, x comma y, right? So this x equals and y equals is more for us or anyone who's reading your code later on than anything else, right? R doesn't need it, but it doesn't hurt to put it in there. I get lazy and I just remember, okay, plot x comma y, great. So looks like my plot didn't change, but I assure you if I flip back and then flip back another one, right, I actually have 2 of the same versions. Nice. My third option for making this exact same plot is using that tilde character again. So that tilde character, again, I'm going to read it as by, right, or versus, or as a function of. So make a plot of the desired weight by their height. The difference being that now I have to have y tilde x. And so we have to keep track of, okay, so it's at either x comma y or y tilde x, right? Y by x. But if we run this, we won't even be able to tell the difference because it'll look the same. But I assure you, they all generate the same thing. Cool. So now, on your own, using the data set that you found, you are going to summarize the categorical variable that you have in a table, right? So where we started. And then you're going to make a bar graph of your categorical variable, and then you're going to discuss it just briefly. Maybe something as brief as group 1 is slightly higher than group 2. Question 3, you're going to visualize both numerical variables with histograms, right? So make 2 separate histograms for each of one for each of your numerical variable. And then you're going to discuss them. Things like the shape, the center, and the spread. Then I want you to make side-by-side box plots, or just one side-by-side box plot of one of your numerical variables by one of your categorical variables. I only forced you to have one categorical variable, so that's why I'm only making one box plot. And then you're going to discuss those, right? Can you see any differences between your groups, right? The groups in your categorical variable, and just pick one of your numerical variables to do that for. And then you're going to make a QQ plot for each of your numerical variables, right, with the QQ line, and then discuss whether it looks like they follow a normal distribution. This should match what you said about your histogram. Right? If you said it follows a normal distribution, then your QQ plot should be fairly close to that QQ line. And then finally, I want you to make a scatter plot of your two numerical variables, right? One versus the other. And here you've got 3 different ways to make a scatter plot. So you've got things to choose from. All right, great. So now you know how to visualize categorical and numerical data. How do I stop this? Ta-da! See you later.